Good morning. Well, thank you, Farah, for that introduction. Style over substance, the folly of the digital design revolution. Crikey. So after Malcolm Turpin's excellent talk last month, Farah approached me and said, well, Ed, what are you going to talk about? How are you going to top that? And after a bit of thought, this seemed like an exciting and quite a challenging title to work to. Standing here now, it seems a bit daunting, if I'm honest with you, but I'll try and do it justice. So I should start with managing a few expectations. First of all, this is not going to be a rant about why there's never enough yellow tracing paper in the office, despite the title slide, although that is an issue that we need to sort out. Neither is it going to be particularly about BIM. So there's a lot of noise at the moment about BIM and what it is and what we can do with it. What I want to talk about is more about using digital tools at the design end, the conceptual generative end of the process, rather than how we document or construct or look after our buildings. And I hope this is also not going to be an overly technical talk, although it's a subject that I have a kind of long passion for and interest in. I'm not an expert in this field. In fact, if truth be known, I'm a bit of a Luddite. But in a way, that's part of the point I want to get across. I want to explore how we can take these digital tools and this approach to design and make it more mainstream and use it on more everyday buildings rather than it remaining the preserve of sort of computer super users, if you like. First section, legibility. This is going back a bit, I'm afraid, but this is sort of the start of the journey for me. When I left university in the mid-90s, I left feeling that I had a pretty good idea of what good building design looked like. It was a view formed by, I guess, the architectural vogue of the time, the then British high-tech avant-garde, firms like Foster's, Rogers, Hopkins, Grimshaw's and others. And what all of these projects and these architects have in common is within their buildings, they have what I would call a holistic legibility. There's a clarity of diagram. You can understand how the building works and there's a clue to how it was constructed. And this seemed to me to be very good. This seemed to be a really good approach to creating good building design. And I was convinced, as a young structural engineer, that the future lay in perpetuating this approach, coming up with ever more refined, resolved, and legible diagrams for buildings. Inevitably, what happened next was almost the complete opposite of that. Chapter 2, illegibility. So sometime in about 1998, this image landed on my desk or possibly on my screen as an attachment to some newfangled wizardry called email. It was a 3D rendering, a computer-generated model built in a virtual world where gravity and Newtonian physics didn't really apply. And it was the concept design for a new pavilion building that would sit inside the Millennium Dome, and it was generated by the office of Zaha Hadid Architects. And to me, this represented a bit of a shift, a kind of new breed, if you like, an architecture not based on legibility, but on quite the reverse, an architecture based around complexity, illegibility. Our job here, as engineers, was not to find a clear and resolved engineering diagram, but really to find a structure that would fit, or as best we could make it, within this predefined sculptural form. A process sort of brute force, if you like, but one that certainly required us to harness all of our modelling and analysis skills in order to really understand the slightly tortured and non-intuitive load paths that needed to exist within this structure to make it stand up. In a way, then, this sort of represented the antithesis of what I felt at the time was a good design process, what a good design process should look like. But as a project, it was still a very stimulating engineering challenge nonetheless. And eventually we solved the puzzle, and it was built. The frame was, in some ways a bit clunky, but the overall result was a very exciting building, or at least a very exciting, large, inhabitable sculpture. In a way, it's a bit of a shame the New Millennium Experience Company couldn't find anything terribly interesting to put in it, but to be fair, there probably wasn't much money left in the pot at that point. Anyhow, this project, Arup job number 55191, which is emblazoned on my mind, really did change my view of where the future might lie, and it was clear to me that these new digital design tools were bound to play a key part in what was coming next. And whilst I was proud of what we'd achieved on this project, I couldn't help feeling that in a way it was a little bit folly. It was a kind of bravura, something there, a bit showy-offy, but you know, that was its purpose in a way. But I couldn't help thinking that we ought to be able to apply these tools, this liberating technology, to something a bit more fundamental, a bit more useful. And I wasn't alone in this view. Next chapter, embedded intelligence. Around that time, I was introduced to a professor at RMIT, that's Melbourne Institute of Technology, a guy called Mark Burry, who some of you may have heard of. This is not Mark Burry, clearly. This is, in fact, Antonio Gaudi. Because as well as teaching at Melbourne as a full-time job, in his spare time, Mark was completing the design of Gaudi's Sagrada Familia Cathedral in Barcelona, which was quite a hobby, I thought. And Mark explained to me that Gaudi's incredible sculptural forms were actually based on a fairly simple set of geometric rules. He used two-dimensional templates and connected together by plumb lines, string lines, to create these complex ruled surfaces, but to define them in a way that could be understood and could be built by traditional stonemasons. He also explained to me that there wasn't a full set of plans explaining how Gaudi had intended to complete the missing bits of the cathedral. So to fill in the blanks, what Mark had done was built a 3D model, but one with a difference, a model built using software he'd borrowed from the aeronautical industry. And the difference was that the model wasn't based on an explicit geometry, it was based on an algorithm, a set of rules that followed Gaudi's constructional logic. And he used this model as a tool to help him fill in the blanks, design the missing bits, but in a way where he was fairly certain he was creating geometries that would have been similar to what Gaudi had intended. And the result's pretty stunning, I think. So he'd effectively captured the DNA of Gaudi's design method, and by linking this to the latest modelling software, he'd created the generative design engine. To me, to my mind at the time, that was an absolute game changer. This was a way of embedding intelligence into a digital model, allowing the process to become holistic again, where the engineering logic and the construction logic didn't need to follow a predefined sculptural form, but it could inform it in some way. So this was very different to the process we'd had to use when designing the Mind Zone. It seemed to me like a bridge between this holistic legibility of the past and the then vogue for complexity of the present. So I and others started to think about how this intelligent modelling could be applied to our projects. But the basic idea is that you might start with this geometric model at one end that was based on a set of rules, and you might link it to a whole load of analysis in the middle that might be the structural analysis of the building, daylighting analysis, spatial analysis, or whatever it was. And that by combining the results of that and modifying the model based on a set of predefined rules, you would end up with a series of design solutions, generate a series of design solutions in a sort of semi-automated way. So to describe what the output of that process might be, another diagram. So if we think of the page as the design space, where any point on the page represents a given design solution, then there will be some solutions that will be that will work better for different criteria. So say all of the dots in the blue circle, these are solutions that stand up, they work structurally. All of the dots in the green circle might be design solutions, buildings with adequate daylight, whatever it may be. And hopefully, somewhere in the middle of that diagram is a sweet spot, the little black bit in the middle, which includes only solutions that conform to all of the relevant criteria. Now, as a diagram, this is not necessarily related to a digital process. We do this every day when we design buildings. The difference is that we get to that sweet spot by experience, learned intuition, trial, error, debate, collaboration, and compromise sometimes. But the opportunity to us seemed that we could develop a digital generative process that would always lead us directly to that sweet spot, only a process that would only deliver solutions that conforms to all the relevant criteria. And it might generate variants, solutions that we wouldn't have been able to think of our own accord, and it might get us there a bit quicker too. That was the benefit. That's where I thought this could take us. And it wasn't about giving up control of the design to the computer either. It was just shifting where the kind of human intelligence had to be inputted into the process. It was about designing the rules of the game. It was about designing the tool, designing the algorithm, not designing the building. You get the algorithm right, and the building should design itself. That's where the opportunity, I thought, seemed to lie. It seemed like a very compelling vision of the future. It didn't take that long before I had a chance to sort of try this out, if you like. So it turns out that Mark Bury, the cathedral guy, had a partner in crime, another Mark Goulthorpe, who was an architect that was exploring similar types of ideas. Both Marks are as mad and brilliant as each other. And Mad Mark II had a project on the South Bank, which was to put a single-storey extension onto the top of this existing residential tower and to enclose some of the sort of terracing at the top that was very windy. And his ambition was to generate the form of this enclosure using a rule-based model that conformed to spatial and engineering criteria. He wanted the whole process of designing and making this building to be as rigorous, precise, and performance-driven as, say, the design and construction of a racing yacht. And this was the result. So we have these splines that form a minimum surface to enclose the required volume, that's then faceted because we wanted to make it out of flat panels, and the depth of the facets responding to the structural demand within the system, and the ratio of the solid panels to the glass panels responding to getting adequate daylight within the space and getting the right thermal performance for the envelope. That was how the whole geometry was generated. But hang on, I hear you say, that's just a crazy shape. And in a way, you'd be right. You'd be right. It's true to say that through the process, the design had become far, far too complex somehow. And maybe Mark had a preconceived aesthetic in mind as well. It turned out that the modelling required some really, really expensive software, and it required a computer scientist with a PhD to run the software. It was a very steep learning curve, and actually it was pretty bloody difficult. And I know there are others in the room that worked on the project can attest to that. So eventually we ran out of time, and the client sort of ran out of patience, and it got canned before the design was completed, so the project never happened. We'd failed in a way, we'd failed spectacularly, but although we'd failed, I think we all remained convinced that the process had enormous potential. Maybe we were kind of reaching a bit too far for where things were at that time. But I felt sure that within a few years, this type of approach would certainly become the norm. It would become the mainstream. Now, all of this was about sort of 98 to 2003. So what's happened since then? Has anything changed in the last 10 years? Well, certainly the tools have evolved. You no longer need a bank loan or a PhD to drive the software. Programs like Rhino and Grasshopper becoming fairly ubiquitous. So where are we now? Okay, we're still building crazy shapes on an even bigger scale. And I suppose that according to my definition, this is in a way still a folly. The engineering and construction logic does not drive the form, it certainly follows it. But this is also, in my view, an incredible piece of engineering, and one that certainly pushed all of our modelling and analysis skills to the very limit. It doesn't have that embedded intelligence that I was talking about necessarily in its modelling, but then again, it's a sculpture. The engineering should follow the shape and not the other way around. So I think we should celebrate this building, or this sculpture, for what it is, because it's not a building. This is a current project that we're working on that's a bit more building-like. It's 2 greenhouses for Bombay Sapphire. Again, it's a complex geometry, but here we've used a rule-based model to help simplify that geometry. So we're able to understand how changing, for example, the pleat angle might affect the shape of the glass panels. And we can play around with different geometries very easily, very quickly, to simplify the construction without losing the essence of the sculptural form. So we can test whether singly curved strips of glass will work equally as well as doubly curved strips, but obviously easier to build. So this is a step forward, I think. Here the construction logic is driving the design, via this digital design and delivery process that also automatically generates the full cutting patterns for the panels. It's a move forward, but it's still not driving the design using the engineering criteria, just the construction logic. So here's another example, which I think is a really good demonstrator of where we're at. It's the current state of the art. This is the Casque Stadium project in Saudi Arabia, and it's a project that is being delivered under an incredibly tight timescale. And clearly there are significant engineering challenges in a major building like this, particularly the design of the stadium roof. And here we have used a parametric model to set out the roof geometry, and the model is linked to this schema. So this is the algorithm. These are the rules of the game that define how that geometry is set up, and this is what we can play around with to pull the geometry in and out and link it to the results of our structural analysis. So the result is an optimized structure, one that is self-generated to an extent based on this algorithm, and the deliverable is a fully detailed design that can get plugged straight into the BIM model. And we're building it. So this is a project that was originally, we were asked to go from sort of concept to completion in 36 months. Halfway through the process, that got changed to 24 months, and we're still going to just about do it. And that's been partly, or to a large extent, I think, enabled by the use of these digital tools and by being able to automate the design process in the way that we have. So here we are, this is it. This is no longer folly. This is reality. But it's still not quite there because all we've done here is we've optimized one performance criteria, just the structural design, and only for one bit of the building, just for the roof. It's not the all-singing, all-dancing version that I was hoping for and that I'd imagined. So is this panacea just a fantasy, really? Have we kind of plateaued here? Has the digital design wave broken? Is this the end of the road? Well, here's one final example that I think, to me, offers more hope. It's a current proposal for low-cost, prefabricated housing. It's not a project that we at Arup are currently involved in. It's a research project at MIT being led by Mark Goulthorpe, Mad Mark II from the failed Tower Top, who is now an associate professor at MIT. So like most modular housing schemes, it's a kit of parts, essentially. In this case, happens to be made from thermoplastic panels that are snap-fitted together. But the step change here is that the design of the components and the different configurations, the way that they can go together, is based on a rule-based model that conforms to some fairly simple criteria. So size of rooms, span of floor plate, number of windows, size of windows, orientation. And the intention here is that with the right user interface, that anyone can design themselves a good house. So that the system will only allow you to configure things in such a way that you hit that sweet spot in the middle of the design space diagram. You'll only ever end up with a house that works. Once you've designed your house using the tool, the model automatically then generates all the machining information needed to CNC cut the panels, 3D print the components so that the whole lot can arrive flat pack at your front door ready for assembly. It's still a research project, but it's pretty close to reality, and it really does do what I think we all thought that we wanted to achieve with this process. Here, Mark has totally suppressed the desire to impose any kind of architectural aesthetic. That's not what it's about. It's not about geometric complexity either. It's very, very simple. It's not a boutique project trying to exploit these tools for their own sake. To me, this represents a sort of honest, performance-driven design where the aim is to deliver something socially useful with infinite variety and high quality. This, to me, is what the digital design revolution has been aiming for. It's what it's about, and we're nearly there. This is not about style. This is about value. It's about substance. Thank you.
I thought it was extremely interesting and very kind of provocative. I was saying afterwards, you know, I'm an architect, and I kind of sometimes think that architects get in the way of the kind of structural logic. So I think there's a kind of structural logic, or the logic that kind of engineers apply to bring a discipline to our design process. And I suppose what I kind of found this morning is that just maybe there's a way of, or there's a way is emerging of kind of reintroducing that kind of discipline to give a kind of an economy of means, I guess, to the realization of some of the more extreme forms that many of us in our profession are producing. So I think very interesting kind of juncture. And I suppose the kind of the hanging question is kind of what next, and I guess that's the subject of another debate and another talk on another day.
I thought it was absolutely fascinating. Yeah, no, it was really interesting. There was a good analysis of those kind of the legible and the illegible, and I thought it was a really good, discussion that went with it. Really, I'd have loved to be able to contribute more, but I think I need to watch it through again on YouTube and kind of understand it really a little bit more, because there was a lot of intellect there, and as you said afterwards, there was a lot of good summing up at the end, and I'd like to just kind of understand the kind of flow that I've been through as an architect anyway, seeing all sides of that.
It was actually very interesting. The sort of work that Ed is looking into about genetic algorithms is very much in line with what we tend to look at. So we look at nature as a source book of ideas for solutions that have been tried and tested and could be applied to the real world. And we see genetic algorithms as a fantastic way of applying that. And since we're very much in line, I would very much like to get Ed to kind of work on a few projects that we're quite interested in looking at. Obviously, I can't say much more than that about the projects, but I think it's a fascinating area and is without a doubt the future of architecture, linked up with 3D printing.
It's fascinating to hear about the way that computers are helping make things like the stadium building far more efficient and quick, and it's bound to be an enormously useful tool the more we can use it and get used to getting the economies out of getting buildings like that up quickly and efficiently. So I think it was wonderful to hear about that.
It's very useful for me as a young professional to be able to see this holistic overview of all the current technologies, and I think it is quite healthy for the industry to have this kind of event. It allows us to think beyond the day-to-day obligations and how we actually use what we have. So congratulations.